Okay, so you already know that whenever you've got an atom, right, you're going to have the nucleus, which has got an overall positive charge to it, okay, because that's where the protons are. And then you're going to have electrons that are going to be roughly at certain distances from that nucleus. Now, they're not going to be in just circles. There's going to be some spheres. There's going to be some parabolas. There's going to be some different, weird shapes based on what kind of orbital they're in, S or P or D or F. Okay, but you can kind of generalize it and say, hey, they're going to be in either energy level 1, or level 2, or level 3, and so on. Electrons, because of the off-bout principle, which I mentioned in one of the other videos, are going to want to get as close to the nucleus as possible. Okay? So there's an electron. If he's given his choice, he could be anywhere in here, but he's going to be the most stable at these certain distances. And he's going to be the most stable as close to the nucleus as he can get. Okay? Because that's where he has the least potential energy. You can think of the nucleus kind of like the ground. Okay? It could be anywhere. It's most likely going to be there. Now, every once in a while, because these electrons are in motion constantly all over this atom, sometimes something is going to happen to this atom, and this atom is going to absorb energy. Okay? Now, that energy could be electricity, it could be heat, it could be light, it could be any number of different forms of energy. But that energy is going to come in, and it's going to get picked up by one of these electrons. Now, when one of these electrons gets energy, it's just like a little kid at a birthday party, full of Kool-Aid. It's going to get all jazzed up on energy, and it's going to jump up to a higher energy level. Okay? And it might jump up a little bit, it might jump up a lot, depending on how much energy it's soaked up. Okay? Now, it can't stay up there, and it can't hold on to that energy because it's not stable. So, it's going to spit that energy back out, okay, in the form of light, okay, specifically in the form of what's called a photon, just a little packet of light, and when it does, it's going to fall back down to where it was. Okay? But this is when atoms give off light. Okay? This is all light everywhere. This is light from the light bulb, from the projector. This is light when you go heat up a burner on your stove and it starts glowing red or orange. Okay? Any light anywhere happens because of this. It happens because energy is making electrons jump up, and then when they fall, they emit that packet of light. Now, depending on how many electrons you have, depending on how far they fall, you get different patterns of light. And that pattern of light coming off is what's called the atomic spectra. Okay? Spectrum of light, range of light, like a rainbow. This is what you saw when you used the spectroscopes to look at the different light bulbs and see the different pattern of lines they gave off. This is also, when you did your flame tests, what caused those different elements to burn different colors. Because you were energizing those atoms by getting them hot, and so they were jumping, those electrons were jumping up and falling back down. When they fell back down, they were giving off different patterns of colored light. We use those patterns to identify what elements make a light source. Okay? Whether it's from a light bulb, whether it's from a star. Okay? That's how we can tell what elements are present in anything that's giving off light. Any questions?